Okay, so what we want to do today, 9:21, our objective is to find a quadratic model. Quadratic model to represent a scatter plot. Okay, write that down. I'll explain what that means. So, the word quadratic really means some x squared equation. And we've seen, Emily, question?
I was just going to say, are we going to learn standard deviation here?
No, I do that in my algebra, but I could teach it to you.
Well, no, I'm just asking.
Yeah, it's a good question. So, we know that the x squared equations look like this. I mean, we've seen parabolas. They're going to look either like, they're either going to look like this. There's our parabolas, right? Or they could be even upside down, right? And what we did in our warm-up is we started with just 2 points, right? 2 points in our warm-up, and we came up with some kind of x squared equation. That was our warm-up, right? In fact, we take a look at our warm-up, we wound up with just 2 points, and we got some x squared equation. We came up with 2 points, and we came up with some, because this really is an x squared equation. This really is an x squared equation. But if you have a lot of points, we're going to need help. We're going to need the calculator to do it for us, okay? So first of all, I'm a track coach, and this should make sense. If everybody got on the track and ran one lap, that's a 400, one lap, okay? Some of us will go faster than others, right? I'm pretty sure if we put Braden on there, he would clean up. It's in his family's blood. He'll probably play baseball, but that's okay. I forgive you, Braden. However, we know that if the older you get, the slower you get. That's where I'm at. You get 55, super slow. Or if you're super young, right? If you're just a little kid, you're going to run slow. So somewhere about maybe 22, 23, 24 years old, you're going to run the fastest, right? So let's make a scatter plot. So what I want to do is age, that seems to be what's driving this whole thing, so we'll put age down here on the bottom. And we'll put our time here. So when we get to Thursday, the easiest question is just the scatter plot. Sometimes kids don't do the scatter plot. I'm always, well, why didn't you do the scatter plot? It should be easy, right? I'm going to go by 5, so I'll go 10, 20, 30, 40, 50, 60, because that way all my ages should fit on there. And times, I'm going to do a squishy, and I think you'll see what a squishy is. So if I do a squishy, this is a little squishy, so I'm going to squish down. That's supposed to look like that. Doesn't look very good. I'll start with 50. I go 50, 60, 70, 80, 90, 100. Yeah, that should work. 50, 60, 70, 80, 90, 100, 110, 120, and 130. Good, it fit perfectly. Okay, and this is in terms of seconds, right? So 120 is really taking 2 minutes to go around the track. 60 seconds is really like 1 minute to get around the track, okay? So we've got our scales. All the scatter plot is a dot to dot. So at age 10, we'll go to 123. So we'll just estimate. 123 is about, it's about there. So I'm just going to estimate. So I'm just going to do a scatter plot. Age 13 is about 105. So I'm just putting down my dots. Age 15, about 68. Much faster. I mean, you're getting younger, so you're getting faster, right? 68's right about there. Age 22, 55. And then we start to slow down because we're getting older, right? So age 30, we've been sitting on the couch too much. 61. Age 41, we're starting to get old. 70 seconds. And then finally 55 is 130 seconds, which is pretty slow, but you're getting old. I'm getting old. Now, it's not a very good looking parabola, so it would be hard to get all of these points. I could try and draw what I think might be the parabola. It might be something like this, maybe. I'm just kind of trying to sketch it and fit it in. That might be about the best parabola. So to come up with the equation of this, we're going to let the calculator do it, okay? So I'm going to write down the steps, and I want you guys to follow along, okay? I'll give you a minute to get caught up, and then give me thumbs up when you got the scatter plot, okay? Thumbs up, scatter plot. Let me see. You guys still working on it? Okay, I got 1 thumb up for scatter plot, 2 thumbs up, 3, okay, 4, there's 4. When you get this 5, good. When you get the scatter plot done, because everybody needs to see how I do this, okay, on the calculator, okay? So, we are going to use this button here called Stat. So we're going to push the Stat button, okay? The word edit means to change or make. So I'm going to push edit or just enter. And then what I have is a list 1 and a list 2. Okay? Hopefully you guys have list 1, list 2. I have numbers in my list 1, list 2, but they're different numbers. And what I want to do is just get rid of these numbers. Okay? So I'm going to try and clear my list. So do you guys have numbers in your list?
I cleared them.
Yeah. Did you clear them already?
Yeah.
Awesome. A lot of kids don't know how to clear them. So to clear my list, I highlight my list name, right? I highlight my list name. I push clear, down arrow. Go to list 2. I highlight list 2, highlight the name. I'll push clear, down arrow. Does anybody need any help right now? Seriously, anybody need any help? Okay, good. So then we're just going to enter our data. I'll let age be list 1, and I'll let time be list 2. So I'm going to go ahead and enter my data, right? All right. About 10, 13. We've done some of this before, right? With the linear regression. That helps. We've done it before. Okay. And then I'm going to, for list 2, I'll put my other numbers, my time, and I'll put 123. Enter 105, 68, 55, 61, 70, and 130, right? So I entered all my data. Good. Let's let the calculator do the work, okay? Thumbs up, everybody have the data in? So we've done this before, but we're not going to do the linear regression. We're going to do the quadratic regression. So I go back to Stat. So push the Stat button, and I'm going to go over to Calculate because I want to calculate an answer. Okay? So hit Stat, the Stat button, go to Calculate, and what we want is this one, number 5. We want the quadratic regression. We want the linear, we want the quad. So I want the quad reg. So I'm going to push Enter. I'm going to go down to Calculate, right? Enter. Okay, here. My equation says y equals ax squared plus bx plus c. So it's setting me up. My a is 0.14. I'll round to 0.14. I'll put that there. My b is negative 8.65. I'll round it up, put that there. My c is 185.78. I'll put that there. So I'll rewrite my equation as y equals 0.14 x squared, because I'm rounding, minus 8.65 plus x plus 185.78, okay? How am I doing? Okay, thumbs up. If you did not get this, please raise your hand and let me help you, okay? If you didn't get it,
Well, I put in my numbers, but it's really hard.
let me see. What did you get?
Huh?
Braden, did it not work?
No.
You in there? Okay, so now, I've got the equation. Was that pretty easy? Everybody agree that's pretty easy? Let the calculator work. Now, the fastest time has to be the vertex. That'd be down here somewhere, right? Fastest time and fastest age. Okay, it's got to be down here. It's got to be the vertex. It's got to be the fastest. To get the vertex, we have an equation. We have an equation. Our age negative b over 2a. We have an equation. We have that little mini equation which we've learned before. Our b is negative 8.65 and our a is 0.14. So I'm going to go a negative 8, negative, right? Double negative 8.65 over a 2 times a 0.14. I get my double negative, which really makes an 8.65 divided by 0.28. And I'll let my calculator figure out what that age is, okay?
What?
So I'm going to use my equation, negative b, there's my negative b, over 2a, okay? So I'm using my equation, my little mini equation. And I'm going to use my calculator to figure out what that is, 8.65 divided by 0.28. And I can answer about 31. It rounds up to about 31, okay? And that's pretty close to what you'd see in the Olympics, okay? So my age is about 31 years old. Tiene 31 años. See? Okay, now, how fast does this person go? So we plug it in to find the time. I'm going to plug this in for x. And I'll let my calculator do the work, but I'm going to go 0.14 times 31 squared minus 8.65 times 31 plus my 185.78. And I'll just let my calculator do the work, okay? So I'll go 0.14 times 31 squared minus 8.65 times my 31 plus 185.78. I get about 52.17. That's fast. That's a fast time. So my vertex is right around here somewhere. My vertex would actually be right about there, wouldn't it? Okay, that's all I have. Let me go ahead and stop my recording, and we'll talk about the homework. And we can work outside today. You guys want to